Good morning, good afternoon, good evening, depending on where you are. I am Thomas Scheiber. I'm the Vice President and General Manager for the NEX Network Solutions Group, covering the Ethernet connectivity portfolio, which most of you probably know as the foundational NICs, the IPU NICs, and the AI NICs. What I'm going to walk through today is some of the interesting news that we have around product and innovations that help you optimize networks for tomorrow's requirements. And this is relevant for the enterprise, for the cloud, as well as for the telco environment. With that, let's just dive in a little bit. So clearly connectivity, most of you understand there's the saying, the computer is the cloud. I actually think the network is the cloud. And without a network, you really don't have a good solutions. And so with that, clearly, if we're clicking on some of these verticals, there are different requirements and challenges around connectivity for cloud networks, for enterprise networks, for telco networks, as well as on the IoT on the edge. And they're really driven primarily the challenges around how do I future-proof, how do I deal with some of the distributed nature of how applications are deployed, what kind of application, what kind of response time customers expect from these applications. But if you look at them, very, very similar, but just optimized for some of these segments. And so what you're going to see and hear from me is how the Intel portfolio can address the needs of our customers when they're looking at how to architect and design connectivity solutions based on Ethernet for these different segments. So let me start off as an overview of the connectivity portfolio. And it's quite frankly not easy to talk this, but what we're trying to do is put a frame in place so you can easily look at the total portfolio and then make a decision what probably fit best for you. So one way of thinking about this is what you see on the top. Do you have a standard host or server design and make a decision based on what's the interface card based on that, versus maybe on the other side of the dimension is really you have custom appliances, still x86 host-based appliances, but they're custom designs. Could be iService, could be telco edge service, where you really have more of a premium on the acceleration and performance that you want, and you're willing to go to to custom design. The other dimension that most of you will look at is what's the speed that I really need. And so we have the portfolio that basically spans everything from 1 gig to 200 gig, with you see it on the left side here, the Ethernet controllers and adapters. Then we have what we call a NetSec Accelerators, which are basically PCIe cards that we're offering as a reference design that combine Ethernet controller plus a Xeon ID on that card that allows you to do application offloads from the host, primarily around network and security use cases. Then the next one, which is spanning 25 to 200 gig today in terms of speeds and feeds, is the IPU card. Think about it again. It's a networking pass plus a CPU complex, in this case, an integrated ARM complex that helps with power optimization. Very, very similar use cases to NetSec around infrastructure acceleration offload. And then the last one on the right side is really the set of products that we're working on, what we're calling the AI NIC, which is really built around optimization, what is needed for backend network connectivity in large AI clusters and the requirements in this space. The other piece that I think is very important for you as a user, customer, vendor in the space using these products is really looking at the commitment that we're having across our portfolio to standards, open sourcing around software drivers to make sure they are plugging into the right host OS versions, as well as what we're offering, that we'll get into this, a fabric suite that helps you automating some of these deployments, as well as optimizing some deployments, particularly in the IML space. So wrapping up, if you look at the use cases besides server design, speeds and feeds, if you're on the left side, typically general purpose networking, Ethernet connectivity, PCIe to Ethernet. If you go towards the middle, application acceleration offload, basically there's a CPU complex on the NIC that allows you to run either acceleration or offload of functions that are infrastructure specific onto the NIC. So you free up the host to just run the user applications. And then if you go to the right, you basically have AI networking. Obviously, the lines are a little bit blurry. You see this. You obviously can use an IPU to do AI networking, it's just not as optimized. So that's probably a rough way to look at the portfolio and where the different product fits. So with that, let me actually click on one of each of these and just walk you through some of the cool stuff that we have. So the first one was what you saw on the left side on the previous slide is the Ethernet network adapters and controllers that we have, and literally they span, and this is around and into for a long time, anything from 1 gig all the way up to 200 gig. You're probably well aware of what we're having was 110 gig, 2.5 10 gig, 1050 gig, and there are two new products that are coming out at the beginning of 25. It's the 100 gig and the 200 gig adapter. You see it, the E830 for 100 gig, the E810 for 100 gig, and then the E830 for 200 gig. And really what we're delivering here is functionality that you're used to, that you like, operational environment that you're using that you like, but incremental value for new applications we're looking at, what you need to design on your network. So calling some of these capabilities out, you see, it's around protocol, enhanced support for new emerging protocols in the space. One to call out here is enhanced dynamic device personalization. Clearly, what we continue is doing flexibility around port configuration, because we know there's an absolute need to be backwards compatible with different speeds. Just because you upgrade your host, you might not have upgraded your network and vice versa. We spend a lot of time around optimization around storage over Ethernet, whether this is RDMA, whether it's other configuration options that we have to optimize for those use cases. The next bucket is around precision timing accuracy, support for PTP, very, very relevant in the space where telco space, where you do timing support over the network to synchronize for the endpoints, particularly on the edge. Another bucket, and that's nothing new, but clearly a focus, because we know that there's an importance around manageability and security. Again, I'm coming back to our commitment to standard support. You're going to see DTMF Redfish. You see some of the other protocols that are out there that we're supporting to make sure you can use those adapters in a large fleet and can automate the deployment and the management, as well as having the security. And you see it on the bottom, the secure boot. Really, really important, making sure when you provision centrally device, you actually know that is a device that you wanted to provision, not a device that just pretends to be the same. So focus for us in that space, given the distributed nature of the deployments. And then the last one I want to call out is also support for Open vSwitch, making sure in those environments we're having the right performance and delivering what you're looking for going forwards. So that's a sneak preview, what you're going to see on the E810 and the E830 coming out at the beginning of 2025 for the what we call general compute space for connectivity. So now let me go to the second column you saw on my first slide on the portfolio, which is the NetSec Accelerator. So the idea here really is, and again, this is a reference design. We're, as Intel, don't sell the adapter itself, but we're working with partners, and you see it on the bottom. So reference design, validated options to basically take what we have around the controller capability on the E800 series and combining those with Xeon D capabilities onto an adapter. So think about a standard Ethernet adapter with a CPU complex on. So you can actually use this to run infrastructure-specific functions on the adapter, and again, to offload this from the main host. The question you sometimes will ask is, so why do I want this? So there are two main reasons for this. One is security, and that's why we call it NetSec Accelerator, because you really want to separate out the user space physically from the infrastructure space, so you have less risk of, if there's an exposure on either one of the sides, that you impact the other side, the user or the infrastructure side. That's one main reason. And the other one is just, quite frankly, you want to offload the main host CPU from infrastructure cycles, so you can actually optimize an application while running the infrastructure apps. You want to optimize the user app space, so you can offload the infrastructure apps to the NIC itself. And so some of the use cases that are, say, pretty obvious around is what you can do around AI acceleration, what you can do around security, whether this is security accelerators or whether this is running security functions on the Xeon complex itself, whether this is around embedded quick assist technology that we have as part of Xeon. or whether that's the last one is around the combination of what we can do, interaction between the controller complex and the compute complex on these NICs. It's actually a very, very flexible reference design that you can use to address a lot of interesting application in various segments for your standard server environments. So that was column number 2. Column number 3, you probably heard the term IPU. I'm sometimes jokingly call it's the intelligent DPU, but it's basically very similar to the NetSec, but this is really a single ASIC where you actually have the CPU complex embedded with the Ethernet pass, networking pass of the adapter itself. And so the use cases are very, very similar here in terms of you can offload onto CPU complex, in this case it's an ARM complex, functionality around network security, storage acceleration, or quite frankly, any containerized app you want to run on there, on the CPU complex. And then in addition, what you have in the IPU, you have optimization for network virtualization and storage virtualization in the Ethernet pass of the IPU itself. So you might know the IPU was created with one particular customer in mind, which is Google, which is really using this as their main cloud IPU. But clearly, there's a lot of functionality in there, whether it's network acceleration, as I just mentioned, security acceleration, reliable transport, so you can actually run RDMA and NVMe traffic over lossy Ethernet fabrics reliably. There are a whole lot of interesting use cases, and you see some of them called out here on the slide, where this IPU and the adapter that has the IPU ASIC on is very, very useful. Let me maybe click a few. Trust execution environment, very similar to what I described before. You can separate out physically function that is infrastructure specific on the NIC versus function that are host specific on the main host. Clearly, there's a security advantage. You have an air gap, which for a lot of operational environment is very, very important. Particularly if you actually want to run an as a service model where the consumer is having the app on the host and the provider is the service provider, whether it's inside of an enterprise or it's a private cloud or public cloud model, where you want that air gap. So you just have clear separation of powers. Offload, very obvious. You have an additional CPU complex on the IPU, so you can make decisions what do you want to run on the main host versus when you run on the IPU. You can do acceleration. We call out some of them that are embedded accelerators around crypto in the IPU, very similar to what you heard me saying on the network NetSec Accelerator. And then clearly you have feature velocity because you do have a CPU complex there. You can run containerized apps. You can decide what traffic that goes through that adapter goes into the host, into the CPU complex for acceleration, as well as you have programmability on the networking path around P4 and what you want to do there to customize actually the functionality of the IPU itself. So a truly, truly flexible device in the portfolio. A couple of comments on, and I alluded to it earlier, but it's worthwhile to repeat it. Absolutely committed across the portfolio. I have it here for the IPU, but across the portfolio to support the open community, to embed these solutions, which the larger systems, whether it's the NIC in a host or whether it's in a larger infrastructure environment where you have different assumption as a user, how you want to configure, how do you want to manage the environments. And you see it there on the top, what we are supporting across the board and what we're working on with partners. And we'll see at some of the end when we see some of the links to joint white papers, where we actually have proven this out. So this is not a marketing slide. This is really what we're driving actively over a couple of years now. The other piece I do want to call out, because the title says it's a roadmap. What I showed you today is what we have a 200 gig IPU, plans in place to go to 400 gig and scoping what is needed for 800 gig as well. Just a little teaser here, but clearly think about this functionality is not tied to a speed. It's functionality you want, and then obviously over time you want different speed points with it. The one thing I'm actually very excited to show, and so this is a 200 gig adapter for the IPU that will be available in Q4. So we're basically close to Q4 this year, 2024. It's the second one of the adapters that we have. This one is full height, half length, so it fits in a much more broader set of standard server environments. It's limited to 75 watts TDP, so it fits within a normal PCIe adapter power envelope, so it makes it much easier to use. And what's really, really cool about this one, that's the first one that has the full hardware assist for Falcon Reliable Transport, which I think is one of the truly differentiating capability that most networking operators I talk to are really looking forward to, because if you want to do today reliable transport, you basically have to do a lot of tuning in your network. You have to do a lot of fine tuning just for those workloads when everything else just doesn't need it. Whereas here, what you can do with this adapter is you do this on the adapter and not in the network. The network can run as it is. And for the ports where you need reliable transport, you use this IPU and you use the Falcon capability to deliver reliable transport over standard networks, whether lossy or not lossy, Ethernet networks. And that's really operationally a very easy way to do, because don't touch the network, deliver it where you need at the endpoints. For the host where you run AI, ML, NVMe storage application that do need reliable transport. So very, very exciting, very cool product. And I'm looking forward to clearly use and feedback. The last one I do want to touch on in this presentation in terms of products is what we call the Ethernet Fabric Suite, Intel Ethernet Fabric Suite, IFS. This is really two main things that you're going to get with this. It came out of the high performance compute environments, machine learning environments, where we work with customers saying, hey, how do I do two things? One is tools to deploy large fabrics. How do I make sure, and this is what you see on the right side here, the fast fabric tools. How do I plan for large fabric deployments? How do I verify that I'm within the recommended guidelines? If there are issues, how do I have diagnostic scripts to figure out what's going on, and then performance tuning based on validated design that Intel put together and is updating for various Xeon configuration, various NIC configuration, whether this is the Ethernet adapter that I talked to, whether it's the IPU adapters. Going forward, we'll support the AI adapters, as well as, quite frankly, we're testing non-Intel adapters as well. So you, as a user, have a set of tools to understand how to deploy server clusters optimized for the environments. The other important piece, which is on the left side here, is really around what we're providing here is an open fabric interface provider for the IPU products going forward. And today we're supporting this for the Ethernet products as well. And the idea here really is, how do you get an efficient mapping from the higher layer of the communication library stack onto RDMA, onto the network, to actually really make sure you're not relying on, you have to rely on closed approach, a closed set of software stack that is available in some vendors today, but really having the ability to use open source tools. And that's why, again, coming back to our commitment to support standards and open sourcing of components, so you as a user can actually build this with confidence that you're not at some point being stuck with one vendor only. So we briefly calling here the performance scaled matching 3, the PSM3 capability to mapping communication library requirements onto layer 4, and then further down onto actually all the way down to layer 1 to the NICs and the switches, to make sure you have actually a clean mapping from what the application needs to what the infrastructure needs to deliver. This is not a new product. This exists for years. We do have deployment with large customers, whether it's a large cloud provider or whether it's large research centers that have machine learning clusters in place and using actually these tools. The really, really nice thing about it, will support Intel Ethernet NICs, as well as the IPU NICs, as well as the iNICs going forward, and gives you a lot of flexibility when it comes to deployment. The last thing I want to talk about on the portfolio, you saw a little bit the AI NIC. Again, that's work in process, clearly optimized around backend network connectivity. And so what we have done in the space as Intel, as we do across the board, committed to standard protocols, committed to work with industry partners and large customers, obviously. And so Intel is actually very proud to be founding member both of the Ultra Ethernet Consortium as well as the Ultra Accelerator Link Consortium, working together with other vendors, competitors, customers, to make sure we have an ecosystem built around Ethernet capability, built around the idea of multi-vendor support for both scale out, which is the Ultra Ethernet, as well as scale up connectivity that is needed for these large GPU build outs. So you see this here. We're driving jointly with these partners and customers to make sure we're getting an open ecosystem, making it simpler to get to deployment, to actually get to profitable deployment for our customers by providing choice. So last point I want to make here, and if you're interested, please engage and let's work together. So with that, I want to wrap it up, and just a quick recap. This is an easy sheet for you. A lot of links on here. Is really how do you find information about what Thomas just walked through, whether it's data sheet, product guides, white papers, and more. Structure, you see it similar as what I walked through. Foundation, like the Ethernet connectivity products. The 800 series I talked about. In the middle, the NetSec Accelerator was all these different links I mentioned to you. We do have reference designs with different OEMs, and you see some of them here around different use cases. And then on the right side, the IPU product set is basically running anywhere from 25 gig to 200 gig. And some of the work we have done with different partners in the software space, as well as obviously with the very large cloud provider I mentioned. And so with that, I hope you got a lot of good inspiration what can be done with the portfolio. I'm looking forward for you engaging with us and working together on the future of connectivity and how we can help. Two main links on the bottom, Intel.com Ethernet and Intel.com IPU. You will find a lot of additional information. And so with that, thanks for joining. Thanks for listening. I'm looking forward to working together.